So introduction to the scientific methods, scientific research methods. And then we ask ourselves, why learn about scientific research process? Why learn about it at all? Well, as graduate students, it's a slam dunk answer. Of course, as graduate students, and especially if we are going to be psychologists and associated with the American Psychological Association, the standard model for the psychologist is the scientist practitioner, where one incorporates research, in one's daily practice. So this is something that very important and something that we need to do is to incorporate research in practice. And that means that we are advised and educated and informed as to how to interpret research and how to read scholarly journals so that we remain informed and abreast of current topics and issues. So why learn about the scientific process? Well, we learn the research process, and it provides a foundation for other courses. We become, of course, a critical consumer of information, specifically our own professional information, and believe me, it continues to develop critical and analytical thinking. Critical and analytic thinking. Thinking about what could be wrong with this conclusion. And I'm going to stress this throughout the entire course, that the basis of science and the basis of research is falsification. One's ability to ask the question and then say, is there any way that I can demonstrate that this is false? Is there any way? Because the hallmark of dogma is that it's absolute, it's true, you don't question it. That's the way it is. So we need to always go back to conclusions and say, well, wait a minute. This could have happened instead, or this could have happened instead, and let's try this and let's try that. That is how science developed, and that's the basis for theory development. As it says here, and as I've just said, we learned to critically read research articles, and of course, this is necessary for most graduate programs. What are our methods of acquiring knowledge? Many. The sources for acquiring knowledge include, of course, tradition, borrowing, role modeling, logical reasoning, the scientific approach, intuition, trial and error, experience, authority. All of these are ways or sources of acquiring information and knowledge. But what is intuition? Intuition is knowing without reasoning. It's used to form some hypothesis as a hunch. Now, you'll hear a lot of people say, I have a theory. I have a theory that Mary will choose the chicken recipe instead of the shrimp recipe because I believe that Mary prefers seafood over chicken anyway. Now, that's not really a theory. That's a hypothesis, an intuition, a guess, a hunch. Theories are based upon reams and reams and reams and reams of data and experiments that always seem to point to the validity of the theory. Theories are built from data. We also acquire knowledge from authority, facts stated from a respected source. Now, this can be used in the design phase of the study. One of the problems, of course, with this is that authority can be wrong. Rationalism is knowledge from reasoning. And reasoning to some people, to many people, is also considered common sense. So indeed, rationalism is very important, rationalism from reasoning. Some of the great classic philosophers and wise people in the past used reasoning. And from reasoning, we got all kinds of things, like, for example, gold is the heaviest element, or that there are four elements: earth, air, fire, and water, or the earth is flat, or everything goes around the earth. And the reason for those is not because these people were stupid, but because it was intuitive and they didn't experiment. Unfortunately, many of these ideas went on through the centuries without experimentation, and they got locked into the underpinnings of authority. And therefore, if you do an experiment, you are essentially questioning the truth of authority. So uh, uh, starting, well, even before Galileo, with Galileo's famous experiment testing the truth as to whether heavy objects fall faster than light objects, and his Leaning Tower of Pisa experiment, he was forced to recant the findings of his experiment because they contradicted authority. So rationalism and authority are many times not the best way to acquire knowledge, but indeed they certainly started to alter how we learn things, beginning with Descartes, in that the idea of empiricism is that we measure, we observe, and we measure. We observe and we measure. So empiricism, that is knowledge from experience, observation used to collect data. Some of the philosophers that from which these ideas came included John Locke and David Hume. One of the problems with empiricism is that within it contains researcher bias. That is, the observer himself, biases the observation. So we have to then include and blend in control conditions in order to remove our own biases, because we are built to be biased beings. We see, hear, taste, touch, and smell what we want to. As you can see on the graphic here, we have truths and we have beliefs, and somewhere in between there is knowledge. So, science, designed to systematically produce reliable and valid knowledge about the natural world. Different scientific methods have been popular historically. Let's see. Let's talk a bit about induction. So when we talk about induction, and in fact, there's two ways in which we learn and explore and come to conclusions and use rationalism: induction and deduction. So induction, you see everything fall down, like Newton. Newton eventually came to the conclusion, after seeing everything fall down, the so-called apple hitting him on the head, which really didn't happen, but it's a great story and a great metaphor. But the apple, finally, after all of the induction of seeing things fall, he came to the conclusion, oh, there must be a force causing everything to fall toward it. And in fact, he came to understand that the Earth is a large mass, and it attracts other masses to it, including us. So after many observations, the conclusion from those many observations was the deduction, was the induction, that is, that gravity exists. So on the other hand, one could state that all gravitational objects all masses attract one another. The Earth is a large mass, and a human being is a mass. Therefore, the human being is attracted to the Earth, and there's deduction. Deduction can be dangerous unless it is operationalized very carefully. And you can, in deduction, you can come to a lot of false conclusions called false syllogisms. For example, All policemen have mustaches. John has a mustache, therefore John is a policeman. False syllogism. So induction, deduction. Deduction is going from the general to the specific, like I just did, and induction goes from the specific to the general.